code is not compliant with using SGO cord to support unsecured receptacles from a bus duct. According to the National Electrical Code, receptacles used as a permanent part of a wiring system must be connected to and supported by a junction box, panel board, switch enclosure, receptacle enclosure, or cabinet provided for this specific purpose. This requirement ensures that the receptacles are securely mounted and that the electrical connections are properly protected, reducing the risk of electrical hazards such as loose connections, exposed wiring, and potential for physical damage. The installation described, where receptacles are attached via SGO cord to a plug-in bus duct overhead and are not secured to any structure but supported only by the cord, violates this code provision. The SGO cord, while suitable for flexible connections, is not designed to provide permanent support for receptacles. The weight of the receptacles and any connected devices can strain the cord, potentially leading to insulation damage, conductor breakage, and ultimately, electrical failure or safety hazards. The code makes an exception for receptacles mounted at an angle of 60 degrees or more from the vertical, such as a receptacle outlet strip supported below a kitchen cabinet. However, this exception does not apply to the scenario described, where the receptacles are suspended from the bus duct and are not mounted at a significant angle. To achieve code compliance, the receptacles must be properly mounted within an enclosure and supported by a suitable structure. Here's a breakdown of compliant methods. Firstly, installing junction boxes. Secondly, mounting receptacles within enclosures. And thirdly, considering alternative wiring methods. Firstly, installing junction boxes. The receptacles can be mounted within a junction box that is securely attached to a nearby structural element. The SGO cord can then be used to connect the junction box to the plug-in bus duct, providing a flexible connection while ensuring that the receptacles are properly supported. The junction box should be sized appropriately to accommodate the wiring and connections, and it should be listed for the intended use. Secondly, mounting receptacles within enclosures. Another option is to use a receptacle enclosure that is specifically designed for mounting receptacles. These enclosures typically have knockouts for conduit or cable entries and mounting provisions for attaching the enclosure to a structural surface. The receptacles can then be wired within the enclosure, providing a secure and protected connection. The enclosure should be selected based on the environment and the type of receptacles being used. Thirdly, considering alternative wiring methods. Depending on the application, there may be alternative wiring methods that are more suitable for providing power to the receptacles. For example, if the receptacles are intended to be permanent fixtures, a hardwired connection using conduit or cable may be a better option than using SGO cord. This would eliminate the need for a flexible cord and ensure a more secure and reliable connection. In addition to these general guidelines, it's important to follow all applicable local and national electrical codes and regulations. This includes using properly rated wiring, grounding the receptacles and enclosures, and providing overcurrent protection for the circuit. Here is a more detailed explanation. The National Electrical Code, or NEC, is a comprehensive set of standards governing electrical installations in the United States. It's published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC aims to safeguard people and property from electrical hazards by establishing minimum requirements for electrical wiring, equipment, and systems. The specific section of the NEC that addresses the support and connection of receptacles is Section 406.5c. This section states that receptacles used as a permanent part of a wiring system must be connected to and supported by a junction box, panel board, switch enclosure, receptacle enclosure, or cabinet provided for this purpose. This requirement is intended to ensure that receptacles are securely mounted and that the electrical connections are properly protected, reducing the risk of electrical hazard. The exception to this rule, as stated in the NEC, applies to receptacles mounted at an angle of 60 degrees or more from the vertical. This exception is primarily intended for receptacle outlet strips that are supported below kitchen cabinets or similar locations. In these cases, the angle of the receptacle helps to prevent objects from being placed on top of the receptacle, which could potentially damage the receptacle or create a safety hazard. In the scenario described, where the receptacles are suspended from the bus duct and are not mounted at a significant angle, the exception does not apply. Therefore, the installation is not compliant with the NEC. The use of SJO cord to support unsecured receptacles from a bus duct presents several potential hazards. Firstly, mechanical stress. Secondly, insulation damage. And thirdly, electrical shock. Firstly, mechanical stress. The weight of the receptacles and any connected devices can put excessive stress on the SJO cord. Over time, this stress can cause the cord to stretch, weaken, and eventually fail. Secondly, insulation damage. The constant movement and flexing of the SJO cord can also damage the insulation, exposing the conductors. This can create a risk of electrical shock if someone comes into contact with the exposed conductors. Thirdly, electrical shock. If the SJO cord becomes damaged or disconnected, it can create a potential electrical shock hazard. This is especially true if the receptacles are located in a damp or wet environment. To avoid these hazards, it's essential to follow the NEC requirements for the support and connection of receptacles. This includes using a suitable junction box, enclosure, or cabinet to mount the receptacles and ensuring that the wiring is properly protected. The bus duct is a prefabricated electrical distribution system used to distribute power in industrial, commercial, and institutional facilities. It consists of a series of bus bars enclosed in a protective housing. Plug-in bus duct has openings along its length that allow for the installation of plug-in units such as circuit breakers, fuse switches, and tap boxes. Plug-in bus duct offers several advantages over traditional conduit and wire systems, including firstly, flexibility, secondly, ease of installation, and thirdly, reduced space requirements. Firstly, flexibility. Plug-in bus duct allows for easy relocation and addition of electrical loads. This is especially useful in facilities that undergo frequent changes in layout or equipment. Secondly, ease of installation. Plug-in bus duct is typically easier and faster to install than conduit and wire systems. This can save time and labor costs. Thirdly, reduced space requirements. Plug-in bus duct can often be installed in less space than conduit and wire systems. This is especially important in facilities with limited space. When using plug-in bus duct, it's important to follow all applicable codes and standards, including the NEC. This includes ensuring that the bus duct is properly grounded, that the plug-in units are properly rated for the load, and that the wiring is properly protected. In the specific case of the installation described, the use of SJO cord to support unsecured receptacles from a plug-in bus duct is not code compliant. As discussed earlier, the receptacles must be mounted within an enclosure and supported by a suitable structure. There are several ways to achieve code compliance in this situation. One option is to install a tap box on the bus duct and then run conduit or cable to junction box or receptacle enclosure located near the point of use. The receptacles can then be mounted within the junction box or enclosure. Another option is to use a flexible conduit or cable assembly to connect the plug-in unit to a junction box or receptacle enclosure. The flexible conduit or cable should be properly supported and secured to prevent strain on the connections. In either case, it's important to ensure that the wiring is properly sized for the load and that the receptacles are properly grounded. It's also important to follow all applicable local and national electrical codes and regulations. In addition to the NEC, there may be other codes and standards that apply to electrical installations in specific locations. These codes and standards may be adopted by state or local governments, and they may be more stringent than the NEC. It's important to be aware of all applicable codes and standards before beginning any electrical work. This will help to ensure that the installation is safe and compliant. Here is some additional detail. The grounding requirements for receptacles are outlined in Article 250 of the NEC. This article specifies the methods for grounding electrical systems and equipment, including receptacles. Grounding is essential for providing a safe path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Receptacles must be grounded in accordance with the NEC. The grounding conductor, typically a green or bare wire, must be connected to the grounding terminal of the receptacle and to the grounding electrode system of the building. This ensures that the receptacle is at the same electrical potential as the earth, which reduces the risk of electrical shock. When using plug-in bus duct, it's important to ensure that the bus duct is properly grounded. This can be accomplished by connecting the bus duct housing to the building's grounding electrode system. The grounding connection should be made in accordance with the NEC and should be sized appropriately for the fault current that the bus duct is likely to carry. The overcurrent protection requirements for receptacles are outlined in Article 240 of the NEC. This article specifies the requirements for overcurrent protective devices such as circuit breakers and fuses. Overcurrent protection is essential for protecting electrical circuits and equipment from damage caused by excessive current flow. Receptacles must be protected by overcurrent protective devices in accordance with the NEC. The size of the overcurrent protective device must be matched to the ampacity of the circuit conductors and the rating of the receptacles. This ensures that the circuit is protected from overloads and short circuits. When using plug-in bus duct, it's important to ensure that the plug-in units are properly rated for the load. The plug-in units should have overcurrent protection devices that are sized appropriately for the circuit conductors and the receptacles. The selection of wiring methods for receptacles depends on several factors, including the location of the receptacles, the type of building, and the applicable codes and standards. The NEC provides guidance on the selection of wiring methods in Chapter 3. Common wiring methods for receptacles include firstly, non-metallic sheath cable, secondly, rigid metal conduit, thirdly, intermediate metal conduit, fourthly, electrical metallic tubing, and fifthly, flexible metal conduit. Firstly, non-metallic sheath cable. This type of cable is commonly used for residential wiring. It consists of two or more insulated conductors enclosed in a non-metallic sheath. Non-metallic sheath cable is relatively easy to install and is suitable for dry locations. Secondly, rigid metal conduit. This type of conduit is used for commercial and industrial wiring. It is made of steel or aluminum and provides excellent protection for the conductors. Rigid metal conduit is suitable for both wet and dry locations. Thirdly, intermediate metal conduit. This type of conduit is similar to rigid metal conduit but is lighter in weight. It is also suitable for both wet and dry locations. Fourthly, electrical metallic tubing. This type of tubing is also used for commercial and industrial wiring. It is made of steel or aluminum and is lighter than rigid metal conduit. Electrical metallic tubing is suitable for dry locations. Fifthly, flexible metal conduit. This type of conduit is used to provide flexibility in wiring systems. It is made of steel or aluminum and is available in both liquid-tight and non-liquid-tight versions. Flexible metal conduit is suitable for both wet and dry locations, depending on the type. In the specific case of the installation described, the use of SJO core to support unsecured receptacles from a plug-in bus duct is not an acceptable wiring method. As discussed earlier, the receptacles must be mounted within an enclosure and supported by a suitable structure. The NEC provides specific requirements for the installation of electrical equipment in different types of locations. These requirements are outlined in Chapter 5 of the NEC. The location of the receptacles can affect the wiring methods and equipment that are required. For example, receptacles installed in wet locations must be protected by weatherproof enclosures. Receptacles installed in hazardous locations must be approved for use in those locations. When installing receptacles, it's important to consider the location and to follow all applicable NEC requirements. This will help to ensure that the installation is safe and compliant. The NEC is a complex document, and it can be difficult to understand all of the requirements. If unsure about any aspect of an electrical installation, it's always best to consult with a qualified electrician. A qualified electrician can provide guidance on the NEC requirements and can ensure that the installation is safe and compliant. In addition to the NEC, there may be other codes and standards that apply to electrical installations. These codes and standards may be adopted by state or local governments, and they may be more stringent than the NEC. It's important to be aware of all applicable codes and standards before beginning any electrical work. Electrical safety is paramount when working with electricity. Always disconnect the power before working on any electrical equipment. Use properly insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If unsure about any aspect of an electrical installation, consult with a qualified electrician.